Good morning, everyone. I'd like to thank the organizers of the conference for giving me the opportunity to share my research into cognitive reserve in cerebral small vessel disease. It's a pleasure to be able to present today. My name is Nathan DeJong. I'm a PhD student in the School for Mental Health and Neuroscience at Maastricht University, researching MRI markers and lifestyle factors of cognitive resilience against dementia. Cerebral small vessel disease, or CSVD, is an important aspect of dementia as it's a major vascular contributor to dementia and is strongly associated with aging. CSVD burden is commonly assessed by the presence of hallmark indicators on MRI, namely white matter hyperintensities, lacunes, and cerebral microbleeds. CSVD is associated with stroke, depression, cognitive decline, and dementia. It's important to note, however, that there's not a direct one-to-one relationship between degree of CSVD damage and severity of cognitive decline. Some individuals with a high burden of disease are able to maintain preserved cognition. This individual resilience has been observed in many dementia-related pathologies and is associated with lifetime experiences such as education or occupational complexity. This phenomenon has been termed cognitive reserve. Although an individual's reserve level is associated with these proxies of brain healthy lifestyle, the underlying structure behind this effect is not clear. In recent years, there's been increasing evidence that reserve is a functional expression of the structural connectivity networks in the brain assessed by diffusion MRI. In this study, we test a relationship between structural connectivity networks and cognitive resilience against CSVD-related damage in the general population. To do this, we used data from the Maastricht study, a large population-based study characterized by a deep phenotyping approach, which has enrolled over 7,000 participants, has taken detailed measurements, including 3 tests of diffusion MRI, cognitive test data, medical history, lifestyle factors, and more. In the diffusion MRI, we estimated white matter tracks of 4,759 participants who had data available and calculated the average number and size of the white matter tracks connecting different regions of the brain. Whole brain averages of these values, known as the node degree or the connection weight, were used as a measure of the strength of an individual's structural network. We tested the interaction between structural network, CSVD severity, determined from the previously mentioned MRI markers, and cognition score, derived from neuropsychological assessments. The interaction studied is depicted in the model here. We are interested in understanding how structural networks affect the association between disease burden and cognition. In other words, we're testing to see if connectivity is associated with resilience. We used multivariate linear regression to test our interactions. The analysis was controlled for a range of covariates, including age, sex, and education level, as well as additional risk factors such as cardiovascular disease and type 2 diabetes. The results of our analysis are shown in the table. Regression coefficients and p-values are given for each of predictors' association with cognitive score. For ease of comparison, each predictor was standardized across the available sample. Significant values are shown in bold. As we can see, CSVD severity is, especially in higher levels of CSVD severity, is significantly associated with poor cognition. Average number of connections, or node degree, was associated with good cognition. And furthermore, a significant interaction between node degree and CSVD score was found. Average connection weight, however, was not significantly associated with cognition, and neither was the interaction between CSVD severity and average connection weight. The predictions from the interaction between node degree and CSVD severity were plotted across the observed range in the sample. Note that as CSVD severity increases, the association between connectivity and cognition increases as well in a dose-response fashion. Individuals with the highest level of CSVD burden who were still able to maintain healthy connectivity levels saw limited cognitive impact from the damage. In conclusion, we've seen that white matter microstructure moderates the association between CSVD damage and cognition in a manner that is consistent with the neural reserve hypothesis. This leaves us open to the possibility that activities which increase neural reserve could be important for increasing resilience against CSVD pathology. Thank you for your attention. If you have any questions, I'd be happy to discuss them further. I'd like to take this opportunity to thank my co-authors and the study management team, as well as the Alzheimer's Center in Limburg for their support. Please enjoy the rest of the conference.